Good evening, guys. Am I audible?
Yes, sir.
So today we'll get started with the next chapter, that is applications of integrals. Right. So before that, is there any doubt from the topics that we discussed yesterday? Any problem that was troubling you? Okay, I take it as a no. So
Yes,
next
sir,
we'll
no
go to, the next chapter, that is applications of integrals, which is chapter number 8. So let's see the introduction first. So when you talk about geometry, we learned the formula to calculate areas of various geometrical figures, including triangles, rectangles, trapezium, and circles, right? Right. Trapezius is the plural of trapezium, right? So if I take about a triangle, you will say half into base into height. If I talk about a rectangle, it is length into breadth. So such formulae are fundamentals in the application of mathematics to many real life problems. Okay, that is accepted. But if at all you come across certain irregular shapes, okay, in real time application, if you come across some some irregular shapes or curves for that matter, then how are you going to calculate the area for it? Right. So there, the concept of integral calculus is the one that comes into picture. Okay. So what was our previous chapter? That is, what was integrals chapter all about? We know about the definite integrals. Sorry, we had indefinite integrals and definite integrals. Right. So when you talk about indefinite integrals, you're going to integrate a function with respect to x without limits. In the case of definite integrals, you're going to integrate the function with respect to x with proper limits. But the question is, in the case of indefinite integrals, what is going to be the output? The output will be another function which is technically called as an antiderivative. Whereas in the case of a definite integral, it will be a fixed number, or I can say a fixed value. Right? So here I'm confident that it is going to be some fixed value or a fixed number. But the question is, what does that fixed number or value signify? Any idea? This is the one that signifies the made by respect to x-axis. Are you able to understand? So if I do integral of f of x dx, then I'm trying to calculate the area made by the function f of x with respect to x-axis between the limits a and b, and that value is technically done using definite integrals, and that value signifies the area made by that curve with respect to the independent axis. Is that clear? So to put it in simple terms, the 7th chapter that you have learned are only the basics for you to solve their applications, right? So this chapter is broken into two parts. One is area under simple curves and area made by a curve with a line. And the next part is about area made between two curves. That's it. With that, we are done. So when I talk about definite integrals, see, for example, if I give you a question of integral of root of a square minus x square dx between 0 to 1, then what will you do? You will integrate this function, then you will substitute the upper limit minus lower limit, and you will get a value, right? So what has happened in this chapter, what has happened in the previous chapter is, the case of definite integrals, they already gave you the function. Whereas in the case of application of integrals, the function will not be given to you. It is your responsibility to write down the function along with the limits and then solve the problem. That is the only tricky part with respect to this chapter. Okay, I'll come to that. I'll tell you how to solve and find it out. Don't worry. But these are the basics. Am I clear with this points, guys?
Yes, sir.
Right. Now listen. So if I take a function f of x like this, right, I'm taking a boundary which is x is equal to a. X is equal to a is a line which is parallel to y-axis, and x is equal to b is a line parallel to y-axis again. So this point is a comma 0 and this point is b comma 0. So between the points a and b, I'm interested to calculate what is the area made by this function f of x with respect to the x-axis. For that, what I'm doing is I will consider a small rectangle, the small rectangle, okay, whose thickness is dx and the length is y, so that y is nothing but f of x. The area of that small rectangle, so area of the small rectangle that you're going to consider is y into dx, but y is f of x into dx. Okay, like this, how many such rectangles can I consider between the points P and Q? Tell me, how many such rectangles can we find between the points P and Q? It is going to be infinite number. We don't know. We cannot. We are breaking them into very small chunks. We don't know what is the exact thickness of the chunk, but it is a very small piece, right? So if I have to add the areas made by all these small rectangles put together, then it will give me the area made by f of x with respect to x-axis. For that, what I will do is I will go with integral of f of x dx between the limits a and b. So I need to start with the point a and I need to end with the point b. If I do this, then I will get the area of this blue color portion. Okay. So having said this, we need to understand. So it is not always integral of f dx, f of x dx that is going to be there. Sometimes you can have the function g of y. So if a function, if anything is a function of y, then you will integrate it with respect to y, let's say between the points c and d. Then the meaning of this is you're finding the area made by the curve g of y with respect to y-axis. So the dy is there, right? Dy is the one which is corresponding to y-axis. So this is the area we are trying to talk about. Guys, please confirm, is this clear? Is it clear till this point?
Yes, sir.
Right.
Sir,
Now
I
what
have
we
a
will
doubt,
do is,
sir.
tell me.
In the diagram in figure 8.2, sir, why can't we find the area with respect to x-axis also, sir?
You can do it. You can do it. Sometimes it is easier to find with respect to y-axis because those limits will be an easier number. That is the reason. I'm saying,
Okay.
if and all you want to find the area made by the curve with respect to x-axis, then you'll use this formula, integral of f of x dx from a to b. If at all you want to find the area made by the curve with the y-axis, then you'll use g of I dy between the points c and d.
Yes, sir.
Okay. So I will show both the values, don't worry. So only thing is, when you calculate the area, right? When you calculate the area made with respect to the curve and the independent axis, when I say independent axis, that independent axis is the differential coefficient between the points A and B. See, for example, this is existing. Then what we are supposed to do is, if suppose this area is calculated above the x-axis with respect to x-axis, then this area will come out to be positive. And if the same area is calculated with respect to below the x-axis, then this area comes out to be negative. You're able to understand? Is that clear? So when you're doing this applications of integrals, right, you're finding the area made by the curve in terms of positive or negative value. That is what I'm trying to say. Okay. Now let me do this problem and show. Find the area enclosed by the circle x square plus y square is equal to a square. Okay, let us use the logic. So x square plus y square is equal to a square is what? It is a circle with the center as the origin. Right. No. So if the radius of the circle is a, then what is going to be its area? Is it not pi r square? We already know this fact because it's a regular shape. But what are we doing now? We are trying to find the area made by this curve using integrals. For that, see what is the logic I'm going to use. If I drop a perpendicular, okay, if I drop a perpendicular like this, then this is dx, correct? Listen, I'm taking only the first sector into consideration. So this is dx. Then y is equal to root of a square minus x square, except actually it is plus or minus root of a square minus x square. Why plus? Plus means upper hemisphere, minus means bottom hemisphere. Am I clear, guys? So if I take this part, if I take the first sector, then I can write integral of f of x dx from where to where? From 0 to a, where f of x is nothing but y. So this will be integral of 0 to a root of a square minus x square times dx. Why didn't I take the minus sign? Because I consider it in the first quadrant. So this is the area of the sector, but the area of circle is what? 4 times integral of 0 to a root of a square minus x square times dx. So how will I get 4 into, what is root of a square minus x square, guys? What is integral of root of
x by 2
very
into
good root of a square minus x square
plus a square by 2 sine inverse of x by a.
Sine inverse of x by a. So between 0 to a, so substitute the limit 4 into, if I substitute the upper limit here, this whole thing will become 0, and this will become a square by 2 into sine inverse of 1 minus, if I substitute 0 again, this will become 0, and this will also become 0. So I am left out with this value. So this will become 2a square into sine inverse 1 is pi by 2, 2 and 2 will get cancelled. Answer is pi a square. Right? Am I clear? So this will be the radius of the circle. This will be the area made by the circle with the x-axis. Listen, is that clear? So Rohan, you asked me, right? Why can't we calculate it with respect to x-axis? Now, I'll do the same problem with respect to y-axis and show. See. So if I drop a perpendicular here, okay, then I will write integral of this point is 0, 0 and this point is 0, a. Now I need to take the limits of y coordinates 0 to a square root of a square minus y square dy. Correct? Yes. So this will become, so area of the circle will be 4 times this value, 4 into a square by 2 into sine inverse, sorry, x by 2 4 into x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a between 0 to a. So 4 into, I'll get the same answer, a square into pi square by 2.
Yes, sir, you'll get the same answer.
2, this and this will get cancelled. So irrespective of how you are going to do, you'll get the same answer. I'm sure you would have solved all these problems, but just giving a different perspective that you can solve in any direction that you want, provided it is a symmetrical shape. Now, find the area enclosed by the ellipse x square plus x square by a square plus y square by b square is equal to 1. Remember, the area of ellipse is pi into a into b. Okay, that is what you're supposed to get. So how can we do? If you draw an ellipse, This point is a comma 0. This point is 0 comma b. This point is 0 comma 0. So it will be root of. So what is the value of f of y, guys? Y will be equal to b by a into root of x square. Y square is equal to 1 minus x square divided by a square. So this will be a square minus x square divided by a square. So y will be equal to b by a into root of a square minus x square. Integral of 0 to a. So take the limits of x coordinate. Integral of 0 to a f of x. So b by a, f of x means very simple, man. In that you should have x a square minus x square times dx. So this will be b by a into integral of 0 to a root of a square minus x square dx. So root of a square minus x square dx, we already got the value. It is a square into pi square by 4. So b by a into a square into pi square divided by 4. Right. So this is the area of one sector. So the total area you need to multiply it with 4. 4 and 4 will get cancelled. A and a will get cancelled. How come I'm left with pi square? I made a mistake. It is not pi square by 2. It is pi by 2. Here also it is pi a square into pi by 4. So this will be equal to pi into a. Is that clear, guys?
Yes.
Okay. The next is we need to find the area of the region bounded by the curve and line. So you have the curve y is equal to x square. So y is equal to x square is what? It is an upward parabola. Y is equal to x square. And y is equal to 4 is what? Y is equal to 4 is a line which is parallel to x-axis. So this point is 0, 4. And this is y is equal to x square. Right? So what is the region they are asking? This one? No. So if I'm able to find this point, so which is better, guys? Should I find the area made by it with respect to y-axis or x-axis? Which is easier? I'll find it with respect to y-axis because the limit of y is given. So what should I take? Integral of 0 to 4. I should write x in terms of y. So I can write it as root y dy. But if I write only plus root y dy, then I'm calculating with respect to first quadrant. So this is happening 2 times. So 2 into integral of y dy is root y dy is y power 3 by 2 divided by 3 by 2. So between 0 to 4. 4 by 3 into 4 power 3 by 2. So 4 power 5 by 2 divided by 3. So these many square units will be the answer. So 4 power 5 by 2 means 4 power half, the whole power 5 divided by 3. So 4 power half is 2, 2 power 5 is 32, 32 divided by 3 square units is the answer. Next. Find the area of the region in the first quadrant enclosed by the x-axis, the line y is equal to x, and the circle x square plus y square is equal to 32. So if I take this line, x square plus y square is equal to 32 is there, no? I'll take something like this. So y is equal to x is a line of this format and x-axis. So which part should I take? I'll number them 1 and 2. Which one are they asking?
One, sir.
Yes. So listen, this is the one, this is the place where we need to be careful. If I drop a perpendicular here, then this point is 0, 0. This point is root 32, 0. So how did I get it as root 32? So this is a square. So I got it as root 32. Correct? But what about this point? So to get this point, I need the coordinates of these points, x1, y1. So how do I find x1, y1? So x1, y1 lies on y is equal to x, and it intercepts with this. So 2 times x1 square is equal to 32, x1 square is equal to 16. So x1 is equal to plus or minus 4. So this point will be 4, 0, and this point will be minus 4, 0. Is there anyone having a doubt in this? Guys, is it clear? Can someone tell me why did I find out that point? Because if you see, in this part, in the first part, the area is made by the line. In the second part, the area is made by the curve. So how do I write the equation? Integral of 0 to 4 plus integral of 4 to root 32. Integral of 4 to root 32 is how much? So here y is equal to x. So you will get it as x dx plus integral of 4 to root 32. I'll get it as, so what is the curve? Root of 32 minus x square dx. So it is x square by 2 between 0 to 4 plus root of 32 minus x square is how much? X by 2 into root of 32 minus x square plus a square by 2 into between 4 to root 32. So substitute the upper limit. 16 by 2 is going to be 8 plus substitute the upper limit here. This becomes 0. Yeah. Plus 32 divided by 2, that is 16 into sine inverse of 1 minus substitute the 4 here, it becomes 2 into root 16 is 4 plus 16 into sine inverse of 4 by root 32. So this 8 and this will get cancelled. 16 into sine inverse of 1 is pi by 2 minus 16 into sine inverse of 4 divided by root 32 is 4 root 2. for 4 and 4. So this will become pi by 4. So 8 pi minus 4 pi, answer will be 4 pi. Correct? Guys, did you understand or not? Did you understand
Yes,
or not?
understood.
Okay. So how to validate whether this is right or wrong is, see. I'll tell you a shortcut. So you know the circle, right? What is the area made by the circle? Pi r square. That is 32 pi. Correct? So this
Yes.
is area of circle. So what is the area of the first sector? This sector is how much? It is 1/4 of it, right? So it will be 8 pi. Correct? Did you understand what I meant? So total area of the circle is 32. So area of the circle in first quadrant is 8 pi. Correct? Is 8 pi. Then this line y is equal to x is going to divide the first sector itself into two equal parts. Then what will be the area of half sector? It will be 4 pi. Correct? That 4 pi is what we have got. Had it been an MCQ question, it is simpler for you to solve it.
Sir, can you explain the 8 pi part once more, sir?
Theta. Area of the whole circle is how much? 32 pi.
Pi r
That's clear.
square.
Pi r square. R square வந்து 32. That's clear.
Oh, we divided by 4, sir. Okay, sir. I understood.
Divided with 4, so 8 pi. That 8 pi வந்து in the area. But this line y is equal to x is dividing it into two equal parts. So on the 8 pi half is 4 pi.
Yes, I understood.
So that's why this 4 pi. So our answer is right. So how did I find it? It is dividing into two equal parts because of the nature of the line. Y is equal to x. Y is equal to x is a symmetrical line. Correct? That is the reason why it is broken into two parts. For example, had the question been y is equal to 2x, no, then you can't say two equal parts. So be careful when you're applying logic. Can you guys try this? Find the area bounded by the ellipse. So ellipse is something like this. So this point is a comma 0. This point is 0 comma b. So find the area bounded by the ellipse, whole ellipse, and the ordinates x is equal to 0 and x is equal to AE. AE na focus nartham. Okay. So they want this area. So how to find? How to find? Anybody? So look at the logic. No. It's very simple. Drop a perpendicular. Correct? So what should be the equation that you're going to frame? Integral of 0 to AE. What is the curve? What is this curve? What is this
Defined
curve?
with respect to x-axis, sir.
That is with respect to x-axis. So root of, so b by a into root of a square minus x square dx. Correct?
Yes, sir.
Okay.
And same thing
that's
for
it.
the one below, sir.
So this thing is for the above one, but below also you have into 2. Correct? So remember, whenever you're writing this formula, right, you write it only for one of the sectors. So the same thing is applicable for the bottom sector also. So it will become into 2. So b by a, if I take it outside, this becomes x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. Between 0 to AE.
Into
Okay.
2, right, sir?
Sorry, into 2. So what I will do, I'll write this 2b by a outside, substitute the upper limit ae by 2 into root of a square minus a square e square plus a square by 2 into sine inverse of ae divided by a. Seriya? Sine inverse of ae divided by a minus, if you substitute the other limit 0, 0 தான் வரும். There is nothing to do. So this a will cancel this and this. So 2 and 2 will get cancelled here. So b into e into a square into 1 minus e square is b square. So if I observe this, a square into 1 minus b square is, sorry, a square into 1 minus e square is b square. So this is b. Square root of b square is b plus a into sine inverse of e. So if I take that b inside, b square e plus ab into sine inverse e will be the answer. Is that clear, guys?
Yes, sir.
Yes.
Right. Now we are supposed to solve some problems from the first exercise. I'll do 2-3 problems, then I'll go to the next exercise. I'll explain that also. Is it there or not? Let me check it once. Applications of integrals. So applications in finding the area under simple curves, especially lines, parabolas, areas of circles or ellipses in standard formula. The region should be clearly identifiable. What are they trying to say? So did they teach you the second exercise in school?
No, sir.
Can someone just, huh?
No, sir.
Did this?
No, sir. They said second one is deleted.
Right?
No, sir. Parts of the second one is deleted. Sir.
I'm not.
Like the
I
first
didn't
sum
get
in
you.
8.2.
Sir,
Last
Your
year's
voice is
exercise
breaking,
8.2,
Rohan.
right, sir?
8.2. 8.2 is the area between two curves. Is that there or deleted?
Yes,
What did they
few
say?
sums are deleted.
So it's better I teach you, not a big deal. Because it's not a very big the side. It's rocket science. It's a simple thing, but just was curious to know whether it is there or not. Anyways, we'll get started.
Yes. Sir.
Find the area of the region find the area of the region bounded by the curve y square is equal to x and the lines x is equal to 1 and x is equal to 4 and the x-axis is the first quadrant. So y square is equal to x is a rightward parabola. To this rightward parabola, you have two lines. X is equal to 1 is a line which is parallel to y-axis and x is equal to 4 is also a line which is parallel to y-axis. So this is 1, 0 and this point is 4, 0. So we need to find this area because they told find the area made by this curve with respect to the x-axis in the first quadrant. So for that, what we can do is if you draw part, then this will become dx. So integral of root x dx between the points 1 to 4, because we know that y square is equal to x, which implies y is equal to root x. So root x dx between 1 to 4. So when you solve this, you will get x power 3 by 2 divided by 3 by 2 between the points 1 to 4. So 2 by 3 into 4 power 3 by 2 minus 1. So 4 power 3 by 2 is going to be 8 minus 1. So it is going to be 14 by 3 square units. (14 by 3 square units). Next. Find the area of the region bounded by y square is equal to 9x, x is equal to 2 and x is equal to 4 and the x-axis in the first quadrant. So y square is equal to 9x is also a rightward parabola. X is equal to 2 is here, x is equal to 4 is here, right? And you need to find this area. So between the points 2 and 4. So integral of 2 to 4, we know that y square is equal to 9x. So y will be equal to plus or minus 3 root of x. So I will take only 3 root of x because it is restricted to first quadrant. So 3 root of x dx. Now 3 into integral will be 2 by 3 into x power 3 by 2 between the points 2 to 4. So 3 and 3 will get cancelled. So 2 into 4 power 3 by 2 minus 2 power 3 by 2. So this will be 2 into 4 power 3 by 2 is 8. 8 minus root 2 the whole cube square units. This will be the required answer. Okay. Similarly, we need to find the area bound by the region x square is equal to 4y, y is equal to 2 and y is equal to 4 along with the y-axis in the first quadrant. So x square is equal to 4y is an upward parabola. Y is equal to 2, y is equal to 4. It is taken like this. And the y-axis in the first quadrant. So this is going to be the equation. So x square is equal to 4y means x is equal to plus or minus 2 root of y. So the area that we need to find is integral of 2 to 4, 2 root of y dy. So 2 if I take it outside, root y integral is 2 by 3 into y power 3 by 2 between the points 2 to 4. So it is going to be 4 by 3 into 4 power 3 by 2 minus 2 power 3 by 2. So 4 by 3 into 8 minus root 2 the whole cube. So these many square units. Similarly, you can calculate the area of the region bounded by all other problems also. So you can try them. And what I will do is, I will explain the concepts of 8.2 as well. Right. So till now we saw area made by simple curves with the coordinate axis or area made between a curve and a line. Now the next concept is about what if two curves are given and you're asked to find the area between those two curves. Okay. Let's say you have a line x is equal to a and you have another line x is equal to b. Okay. And you have y is equal to f of x and y is equal to g of x. And these two curves are meeting in such a way, that we are interested to calculate the area between these two curves. Then what you're supposed to do is try to understand, had it been only f of x, then what we would have done? We would have calculated this area by integral of a to b f of x dx. Right. Let me call this as equation number 1. Had this been only g of x between the same 2 points a and b, then we would have calculated this area as integral of a to b g of x dx. Right. So what would have happened is g of x area with respect to x-axis is this thing. But what are we interested? We are interested only in this area. Right. So what are we supposed to do, guys? If 1 is there, 2 is there, you want to find the area between both the curves. What are you supposed to do? Then you need to take integral of a to b f of x dx minus integral of a to b g of x dx. Okay. To put it in very simple terms, whenever you need to find the area between two curves, integral of the limits upper curve minus the lower curve, that will give you the answer. But only thing is, since here in the part of explanation, if we don't know what is f of x and g of x, but sometimes you need to have a clarity to draw the graph to find out which is the upper curve and which is the lower curve, and then you need to solve. Okay. So having said this, I'll explain this problem. Find the area of the region bounded by the two parabolas y is equal to x square and y square is equal to x. So y is equal to x square is an upward parabola and y square is equal to x is a downward parabola, is a rightward parabola. We are interested to calculate this area. So for that, what we need to do is we need to first find the point, the x coordinate of the point where these two are intersecting. So y is equal to x square and y square is equal to x. When you solve them, you will take that x square and put it here. Then it becomes x power 4 is equal to x. So it becomes x into x cube minus 1 is equal to 0. So x is 0 or x is equal to 1. So this point is 1 comma 0. This point is 0 comma 0. So it becomes something like this, integral of 0 to 1. Now tell me, what is the logic I told you? This is the upper, this is the lower curve. So what is the equation for upper curve? Upper curve is y is equal to, y square is equal to x. And what is the equation for the lower curve? Y is equal to x square. So y square is equal to x means y is equal to root x plus or minus root x. And y is equal to x square is y is equal to x square only. So root x dx minus x square dx. Now, I hope you guys will be able to solve this.
Yes, sir.
Yes, that's it. So this is how you solve. So if you observe what is the challenging part in it, drawing the proper graph and finding the points of intersection. Okay. So with this, the theory part for this chapter is over. Okay. I think there are around 7 example problems and few exercise problems. So you can keep solving them. Okay. And in tomorrow's class, I will try to solve some more problems. And then we'll move on to the next chapter, that is vector algebra. So with respect to 8.1, what I can do is I can, it will take 2 days time. I can edit the videos and give it to you, the solutions part, so that you guys try it on your own. If you have any doubt, right, you can refer the videos from the app so that we can save time. Next, we'll go to tomorrow's class, we'll go to vector algebra, then 3D and probability. With that, we'll be done. Maximum, I'll try to complete it by next week. Okay. So in the meanwhile, you guys also have to work faster. Is it clear?
Okay.
Any other
Yes, sir.
doubt?
No doubt.
Any other doubts? Okay. Then we can wind up this.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.